Alrighty. Thank you so much, guys, for inviting me here, and it's a great pleasure to open this conference. So, as a first thing here, we need to do some workout because it's the morning, right? So, please show your hands if you are using agents every day currently, in any kind of form, like ChatGPT or Cursor. Awesome. So we actually have many people here that already use agents. So how many of you actually wrote an agent before? Great. So we have a couple of people that wrote an agent, which is great. And today, I want to showcase how you can write agents in Go, because I'm not sure, maybe one more workout. How many of you wrote an agent in Go? All right, 3 hands. Great. So all of you will now see how you can write an easy agent in Go. And then I have a demo for you guys. So first of all, I want to go through some concepts. So we are all on the same boat with this. Then I'm going to showcase a bunch of code, but you don't need to take photos. I will share the whole repository afterwards with you guys, and then we're going to go to the demo. Now, disclaimer for the demo. It's a very small and simple agent, and it doesn't have any kind of error handling. So it's 50-50 that it will pass, or it just won't work at all. So please bear with me if I try to debug it here on the stage. Alrighty. So first of all, I want all of us to understand the AI landscape, and I like to categorize agents into 4 parts here. If you look at the x-axis, we have copilots and autopilots. And what I mean by this is copilots are basically the agents that you chat with probably every day. Your Cursor, your ChatGPT, or whatever that is, which means what you need is a human interaction for it to actually work. Then it does a bunch of stuff, but you still need that human interaction, and it just can't work by itself. And then we have autopilots. And autopilots really are bound to some events that are out of human events, let's say. So things like there is a monitoring error, or there is an email coming in, and so on and so forth, and you want to really automate stuff with autopilots. The main difference here is that with copilots, you are basically running copilots when you want that human interaction there, and you are running autopilots only when the errors that it makes along the way are not necessarily really big, and you can still retry or you can still fix them, right? And then on the y-axis, we have workflows and agents. So when we look into workflows, what we mean is kind of this drag and drop, or maybe you've seen these workflow managers where you just say, there's node A, node B, node C, and there's prompt, and you basically do and chain those prompts together in a fashion where you literally know what the process looks like, right? So that is when you really know the process and you don't want the agents to figure out anything. But then you have agents. And agents really are, well, here's the start, here's my data, and here's your goal. And go and figure it out, build a plan by yourself, and then try to do something with it. So what we're going to be talking about today is agents, and agent copilots and agent autopilots. And you're going to see both in action, hopefully in successful action today. So we're going to be building this in a tool called Jenkit. And as with any other tool that you probably used, at the core of Jenkit is a prompt. And what Jenkit does for you is a couple of things. So I will just visualize them for you here so that everybody knows what Jenkit is. Because you probably if you tried an API like OpenAI or Anthropic or any other, you probably went there and there's a REST API that you can basically use, and it will return something like a text back, or it will return a tool call or something, and then you need to go back, process it on your side, and again call the API, right? And so this is what the Jenkit does for you in the complete core. Basically what it does is you give it prompt, you give it tools, and then it goes this prompt tool until it reaches the goal, right? So that's the first thing that you don't need to care about when you're using any kind of library, but we're going to be using Jenkit today. And that's the first thing that is kind of optimized for you. So you don't need to figure out what is the best way to pass tool data, what is the best way to have inputs and output schemas. There's a validation for you, and so on and so forth. And so all of this is then wrapped into something called a flow. And a flow, what you can imagine here, is really this kind of let's say, HTTP handler or a middleware that what it does is it brings the authentication data and it brings the observability for you. So for an example, you can pass an authentication token there, and right now it's just a middleware kind of. So it collects all the data for like all the traces, all the logs, and so on and so forth. And again, you're really building the core of your application while Jenkit does all the things for you. And I have a screenshot for you afterwards as well for how the observability works in the UIs. And on the complete top, you have tools and plugins. And if you've used any kind of AI tools or different platforms, you go to Anthropic, you go to OpenAI, you go to Google, one thing that you will see is everyone does the same thing, but does it differently. So the fields look different, the number of options are different, or the names of options are different. And so you can't really just have a single HTTP call and say, I will just change a URL to Anthropic, or I will just change a URL to OpenAI. You still need to work out all the differences between that. And so Jenkit, what it does is it brings plugins, which are basically the layer on top of it that abstract it for you. So instead of saying, hey, I now need to call OpenAI, you just say, I'm just using this model, figure out the rest, right? And tools are, again, a wrapper for the same thing because, again, just like with the REST APIs, tool calls are different on every single platform. So when you want to get a tool call back from OpenAI, it's going to be different than from Anthropic or from Gemini. I have no idea why they built it like this and why they couldn't just figure out a spec together. But now we have Jenkit and other libraries to figure this out for us. Alrighty. So this is how the Firebase Jenkit looks like when it comes to the debugging to the debugging UI. So what you have here is once you write an application in Jenkit, this UI will show up for you. And there's a bunch of things here. So you can look into what kind of models you have from your plugins. You can look into flows that you can run. And we will run a bunch of flows together today. And then you have the tools. And why is this really good is because when you try to debug AI applications, you will soon realize that it's one hell of a job. And 90% of your time will most probably be used by debugging prompts. And it's not really fun, right? Is somebody having fun debugging prompts here? I guess no, right? And the best thing about prompts is you fix one thing and other three things just break. So you kind of want that UI or something that will tell you, oh, I did all of these steps, and here we see 4 steps, but what we commonly see in production is 20, 30 steps. And suddenly there's an error, and you need to figure out from this whole chain, how did you get to that error state, right? And so it's really cool to have some kind of UI that you can actually use to debug these things. What you can do here is you can call the tools as well, and you will see this on the next slides too. So really, this UI to me was the best thing that Jenkit delivered with the observability. So you can get really everything that you need here, and you can call whatever prompts, whatever flows, whatever tools separately. So kind of unit test by yourself. But Jenkit also has evaluations. We're not going to show it today on the presentation, but what you can do is you can define a test set for your flows or a test set for your tools, and then you can run through that. Now, is it going to be cheap? No. But is it going to help you debug faster? Yes. So as with any kind of testing without mocks, basically, because you can't really test prompts with mocking them, it's going to cost some money, but in the end, it's going to be worth it. Alrighty. So let's go to the code part. Initializing Jenkit, and this is going to be hopefully what you will see here is it's fairly easy to work with Jenkit and to create basically the base application, and then you can just build on top of that all your tools and all your prompts. And so what you do here is there are 3 things. You first need to initialize the Jenkit itself with plugins. And so what we do here is we basically provide the Google AI plugin, which is if you go into AI Studio, google.com, I think, you can just bring a token, or you can create a token there. You can pass it as an environment variable. You can see go.env here. So I just have an env file. I put the variable there and load it. Then you add the plugins that you need. So there are currently plugins, not sure if with Go, but there are definitely Vertex, there's Google, there's OpenAI, And there are different plugins that are on the roadmap, which is Anthropic and Llama and Grok and so on and so forth. So the idea here is that whatever you want to use, you can just add a plugin here and then just say, all right, well, if there's no model, for example, I'm just going to add a default model here, which is going to be, for example, Gemini or Claude 3.7 or something. So you don't need to redefine all of those things all over again in tools and in flows and so on and so forth. Then the second part is that you register tools. And Jenkit works in a way where it's you kind of want a singleton instance of Jenkit in your app, and then you want to register all tools to that single instance, and you will see why in a second. And the third part is registering flows. And I like to call flows agents directly, because that's what they do in the end. And what you do is you again register the flows, or you create the flows, and then you will see how they connect with the tools. All right, so this should be fairly easy to set up. And let's go to the tools. Many people think that tools are some kind of magic, but they are in the end just functions. And what I mean by this is you can actually see how these work. You just have a context and you have an input. In Go, every tool input needs to be a struct because they are trying to infer the schemas from it. And then as an output, you can either have a string or whatever type you want. But in the end, that's what your tool call will do and return. Now, tool calls, here you can see just exec. So this is a bash tool, and we will see this in action in a second. Of course, in bash, it's a very powerful tool. So you really want to make sure there is some kind of allow list or block list for this tool, so that you're not just destroying your system. And I can show you that afterwards once we have time. But here, what you really can do is you can run simple tools like this, meaning just use bash. Or you can also call other AI APIs, or whatever you really want in those tools. The tools run on your side. They don't run on the OpenAI or on Anthropic or anywhere else. They run on the machine where the agent is hosted, right? So the way it works is you send a prompt, and the prompt sends back a tool call, and you make the tool call and then send back the prompt, right? And so this way, you basically create the tools on your side. Then you register them, and then by defining like this, you can see the tool in the Jenkit instance. Now, as I said, it's a very simple function. So here, whatever you want to make a tool, you can currently make a tool. You just wrap it basically in this AI tool context and the input and output. And then flows. And there are two parts to this. So flows, as I said, are kind of the, let's say, core of the agents. And so what we do here is they are the primary for prompting, for tool calling, and for authentication and any kind of pre-processing and post-processing that you need for that agent. So what it means is that if you when you define the flow, what you want to do is we have defined the tools, and you can now see here that we look up the tools that are in the Jenkit instance. So first things first, you want to prepare all right, these are all my tools that I will use in that agent. Then I will define a system prompt for that agent. And then on the input, you can actually see a message from the user, right? So all of these things you want kind of defined before you go any further. There's also the session ID. And the session ID is something that I just like to pass really into any flow, which is that defines the session of the user, which is kind of like the chat, right? So if you're chatting with the agent, this is the session ID that's persistent, and so you know how to persist the messages between the agent and yourself so that you can then pass the whole chat to the prompt again and again and again. And then the second part is they implement the message history, right? And so this is the part where we actually make the call to the AI model. And so we first get the previous messages from the session. This is in a SQLite database currently. From my implementation, you can implement it yourself however you want. And then you create those messages. So first will be the system message, and then will be the user message. And before that, there's going to be the previous messages, right? So you're going to basically append all of these. And then Jenkit generate is what makes the AI call to the platform. Now, what you do here is you either have the default model, defined in Jenkit initialization, or you can pass a model here. So here I'm passing Gemini Flash, so Gemini 2.5 Flash. And then I'm passing the messages, I'm passing the tools, and I'm passing max turns. Now, I would suggest that you really take care of this one line, which is max turns, because of two things. First, models have contexts, some models don't have very large context windows. And what you do is every time you do that prompt and tool call and prompt and tool call, you basically take all the messages that are in the context and send them again and again. And so it gets bigger and bigger and bigger. And so that means that with many tool calls or many turns, you can simply hit the rate limit and you're not going to get your result. The second thing is, because you're making these calls in such a fashion where it just gets bigger and bigger and bigger, you pay more and more and more for each turn, right? And so what I really like to do is just make this maybe 10 at the start and then work out from there how many tool calls do you actually need to do the process that you wanted to do, right? Now, in the end, what you will want to do is you want to look into those traces and see, can I do the same thing that I just did, but with less tool calls, right? With less calls to the AI platforms, because then you can actually optimize. And this will be the main point of optimizations for the start for many teams. And it was a very good optimization point for us in production as well. Alrighty. And the last part before we go into demo is multi-agent systems. And just building on top of what I said already, it's simply chaining these multi-turn prompts. So going prompt tool, having that result, and then chaining that towards something else via a workflow. So taking that response and sending an email or putting it into another agent, and so on and so forth. So if you want to look into emerging technologies, I could probably write a list that's probably for more slides, so I didn't. And instead I put here something that's fairly new, I would say. I guess everybody already knows about NCPs, right? But A2A is a protocol from Google that was just released 2 weeks ago, and it's agent-to-agent protocol. So they currently, I don't think there is an implementation or an official implementation, but there is a full spec on how agents can work together and how messages can work together between them. Then there's Agent Development Kit, which actually uses A2A, and that's the only implementation that I know of currently, which is in Python. It's good, but that's kind of the chaining multi-turn prompts with workflows, right? And the only, the main difference between Agent Development Kit and between Jenkit is that Jenkit is far low level. It's a thing where you can really go deep into how your prompts are handled, how your tools are handled, and so on and so forth, and you can actually make the tools. While for the Agent Development Kit, it's more of I already have the tools, I already have the agents, let me just stick them together via workflows, right? So this is the difference, if you guys were wondering and seen Agent Development Kit before. And then there's Jenkit, there's Vercel AI, and others. So there's really a large number of these libraries. And I think you can pick whatever you want, really. There's one for every cloud at this point. But they all have the same concepts. Alrighty, so the demo. And the demo that we have, I was asking a couple of people, what is it that that slows you down during your development? And they said, updating Jira tasks. So, so I thought, okay, well, we're not gonna be doing Jira today. I'm not gonna be torturing you guys here. But I said, okay, well, let's create maybe a simple board as a product manager that will refine tasks and epics and product requirement documents, and then it will send it to an agent that will try to implement that. Now, for the product manager part, I'm fairly sure it will work, maybe on three different retries, but it will. For the code assistant, we will see what it will do. And yeah, if we don't hit the rate limits. Which is another fun part for doing AI nowadays. Okay, so the architecture. I will be the user, and then I will define some goal for the product manager. And the product manager will try to make the epic and the tasks, and then save them into a SQLite database. Now, if you want to look into the GitHub repository afterwards, there's a bunch more stuff there, because I'm persisting the messages, the sessions, and so on and so forth. So you can take that sample if you want to start with something simple. And then the product manager, once it has those epics and once it has those tasks, it will send it to the code assistant agent, which will use just bash to implement everything. And then we can look at the code and see, what it did and whether it's actually good or not. But the part here is I will use a CLI agent, which is this product manager agent. There will be a CLI agent that I will chat with, and the code assistant agent will be an HTTP server. So what Jenkins does for you is you can wrap those tools and you can wrap those flows into an HTTP API, and you can then call them from wherever you want, really, and just get those responses. All right, so demo time. Wish me luck. This is the repo if you want to look into the sample. And I will probably share it afterwards, after the presentation as well, so everybody can see it. And how do I do this? Great. Alrighty. So on the left side, there is the application that we will run, which is the CLI. And this is going to be is it on the left side? Yes. So this is the product manager. And on the right side, we will run the HTTP server, which is going to be the code assistant, right? And I already created a prompt because I didn't want to come here so you can see me type. But I already made a prompt here. And the prompt basically says, make a to-do list app that it provides just REST API, creating, modifying, deleting tasks, updating their status, and it's kind of it, use in memory. And I want the product manager to first go and break it down to an epic and tasks. Now, we're using Gemini here with the thinking enabled, so it might actually take a couple seconds for us to see the first results. And hopefully then it will be able to actually go to the database, break it down, and we can look into the SQLite database as well to see what it did. Now, what it does right now, you won't see much happening for a minute on the right side because it still doesn't have those tasks. But hopefully it is now breaking down the tasks somewhere on the API, and it will return a result very soon. Yep, so this is our first tool call that we have, which is that the product manager, and I guess we're hitting some rate limits here as well because it's gonna be retrying. This is not supposed to be taking so long. But what it has is in its prompt, I say there's a project documentation that it can update, which is the first select here. And I say every time you want to do something, go to the project documentation so you have this high-level introduction of what the project does. And then it goes here and inserts basically the first documentation from what I just gave it, right? So I told it, I want a Go application, I want a simple to-do list app, blah, 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 all of these things. And so it went and it inserted this project documentation with a bunch of stuff right into that single point in the database that it always fetches before it does anything. I don't think we need to read through this, but it's kind of implement these API endpoints, blah, blah, blah. And then it goes again, and it actually created an epic. Did it? Insert into docs. What did it do? Oh no, it went here, and it selected an epic, and then it inserted into tasks. And hopefully it inserted also into the epic itself. We can see here. So what it did here is you can see it inserted all the tasks from what I just gave it. So I think looking at the terminal right now is not really fun. But you can see here at the end, hopefully, what would you like to do, right? What is it that you? So it broke down my request into a PRD, into the epic, and into the tasks. And now it asks me what should I do next, right? So before we do anything, let's check the database. Is it guys big enough? Can you see it? Yeah. And if you look into epics, you can.
Not really.
How do I?
That's Intel here, right? If you go into settings, there is actually a presenter mode. You can just zoom it.
Ooh. Where? Is there view? Ooh, nice. Awesome. Thank you so much, guys. Debugging on the stage. This is what I always wanted to do. Yeah, and you can basically see the PRD here with the functional requirements and so on and so forth. And this, we're not going to be diving, deep into this. How do I get back now? But there's going to be also these tasks here that it said, right? And it said the status is to do here, and all the tasks, right? So we can basically tell it right now that we want just maybe implement task 2, which is implement get tasks endpoint. Set up basic road structure. This will probably need to be done anyway. So we will ask it to do task 6 and task 2. Now you can of course go and ask it to do something in natural language, but we will just stick to 2 and 6 for now. So implement task 2 and 6. And so now what it should do is it's gonna again go to the database because it wants to make sure that nothing changed in between. And then it should send the request to the assistant. But this is gonna probably take some time for the assistant to actually get and again call the APIs and so on and so forth. So if you have any questions in between, please shoot. What is it doing? Oh yeah, this is sending right now to the agent on the right side. It worked yesterday. Yeah, it's probably thinking a lot right now, somewhere on the API, I promise. Yeah, and we have an error generating response. Yeah, this is the magic of using any kind of Gemini APIs right now because they are in preview. So you're probably gonna hit those 500s there, and there's no retry logic. But what we can do is we can try again. I have just exit here, and let's retry. Guys, any questions in between? Because it's gonna be running again the whole thing. Yep.
Is it possible to get reasonable results with, let's say, some local models? I suppose that Jenkins supports some llama.
It does, yeah. Yeah, it definitely is reasonable, but for example, tool calling is, I think, available from 4.0. So 3.3 is very, very bad at tool calling. And the same goes for all Flash models, basically, which are something that you would probably run on the local. It's all of those models are very, very bad at tool calling. So even here, I tried the Gemini 2.5 Flash yesterday for the presentation, and it just didn't work well. For tool calling, you almost always want to use the Pro models. Unless you want to do like 5 retries in between, then it kind of works. But no, let it figure out what you already told it 5 times in the prompt. Yeah, it does something. All right, so this time it looks like it's actually implementing something. Any other questions in between? Yeah? How do you test the agents? That's a good question. So currently, what you can do in Jenkins is you can literally test agents the same way you test anything else, right? It's an HTTP API, for example, for the agent. So in the end, what you can really do is create the same test, just add the prompt there. And one of the things that you will hate about testing agents is you either go with temperature zero and you make it a robot, so it's gonna have all the same answers all the time, or you're gonna stick with the temperature 1 or something in between, and you're gonna need to run the test 20 times to actually see whether it actually works or not, right? And so then you're kind of playing the whack-a-mole with all your use cases. So what we do is we really test things 10 times before we deploy to production, right? So, whoop, what happened? Oh, okay, so it actually looks like, wait, what is it doing? Is it just re-implementing stuff right now? Go ahead, go build. Oh, great. So it did actually implement something, as you can see, guys. And it went and implemented something. So let's see what it implemented. So it implemented main Go, which is going to get tasks handler, which is then going to task store. what is this? And task store is this thing. All right, I don't think it. So it implemented the handler just as we asked it. It created a lot of different things, on its way. So there is definitely some prompting for me to do here, but this is just a demo for you guys, so you can see agent in an action. So again, what we saw here was on the left side, you could see the product manager, so kind of the co-pilot style agent, which is you are the one actually working with it and trying to decompose the problem and so on and so forth. And on the right side, you had an HTTP API, which is an agent that actually implements stuff. Now, this is just a sample to show you guys how these things could work, but your imagination is the limit. So you can go and do things like merge request reviews. You can implement maybe simple issues from Jira, and so on and so forth, and just connect stuff together. That's it from me. Thank you so much, guys. All right, do we have any more questions, or do we have time for questions? So, yes?
So, what are some use cases that you use it for in Kiwi, if you can tell?
Yep, so the main use case that we have is customer support currently, which is, we have definitely a very well-written processes for different use cases. So as an example, if you want a refund for a certain type of flight, you don't need to chat with human to do that. We basically have that process that checks all the stuff in between, and that's what we do with, like, for example, the workflow agents, right? So you have that process. It's not like you go and figure out what this customer wants. It's like we have the SOPs to actually run that. And now the new use case that we have is literally code reviews and making BigQuery queries and stuff like this. So the natural language to SQL became really, really good with good documentation. So I think right now, if you haven't used, for example, the Postgres MCP, which is their official MCP, go and try it because it's really good. Yes?
How do you solve to prevent against the hacking, from the user's perspective?
Yes. So first, you can prompt things, but then that's kind of like the first thing that you should do, right? Like make sure that there are boundaries in the prompt set already. But there are also injection prevention services. So these are many heuristics that they run on the prompt itself. So you can basically have this in front of every call that you make to the service, and it tells you what is the likelihood of the injection attack from that user's message. So for example, if user says, give me your system message, it says, hey, this is likely an attack from the user, and you just won't pass that message. Yeah?
SQLite database is custom or specific to the agent or for every agent?
You can do whatever you want here. It's a...
So it's custom.
This one that I have here is custom, yes. Yeah. So I use SQLite because it was the easiest thing that you could do on localhost. But of course, if you want to persist messages, for example, between different sessions, you will want to use something different. And the options are endless. It's basically a very small JSON from Jenkit, which is not even nested. So you can put it into Postgre, you can put it into Mongo, you can put it very, very want, really. All righty.
Okay, so a quick question. Is it possible to win a Lego today at the conference?
Is it what, sorry?
Is it possible to win a Lego today at the conference? The Lego set by Kiwi.com.
I don't know. You guys told me it's mine? No? No, yeah, it is. Yeah, you can win a Lego set on the conference here at the Kiwi booth. Alrighty, guys. Thank you so much. Enjoy the coffee break, and if you want to chat afterwards, you can catch me here in the space. Thank you again.